I'm wearing a mic so that I can record this material. Okay? So, I'm recording it so that I can post it on Google Classroom. I post it on YouTube, and if you subscribe to my channel, you can do that too, or you can just go straight to Google Classroom. Okay, now, you've all had functions before, but maybe you don't remember, and it's okay. A function is just like that penny machine. You see those sometimes, you put a penny in and you turn a little handle, a little crank handle. You turn the handle. That's a bad looking handle. I got to do better. You turn a little crank like this. That's even worse. Anyway, you turn the little crank, and then what happens? You put a penny in, and what happens? Yeah, it spits out a decorative coin. Have you tried that, Brandon? Have you put a penny in one of those things? You crank it, and it turns out a little decorative coin. That's how functions are. But instead of... I'm going to talk for just a second, okay? I need you to nod. Instead of a penny going in, you put in an X value, and instead of a decorative coin coming out when you turn the crank, you get a Y value or a function of X. F of X, like this. F of X. And it just means that this part is a function of X. And you can do lots and lots and lots of things. Like, for instance, our function machine, this particular one, might go times 3 and then plus 2. Okay? Now let's see what that looks like. I'm going to make a little table here. Well, not that. Let's make this smaller. Now that didn't do precisely what I want to do, but we'll get it. That's better. Not that. Having issues. Okay, so then we'll just do it right down here. This is fine. So let's pick some X values. And I always try to pick a few negative ones and a few positive ones. Something like that. And then F of X. Remember, we're going times 3 and then plus 2. Okay? Our function is going to multiply it times 3 and then add 2. So then that first one would be negative 3 times 3. I'm going to go the other way around. I'm going to go, this will be better. I'm going to go 3 times negative 3. There's my times. And I'm going to go plus 2. 3 times negative 3, what's that, Melissa? Negative 9. Good catch, good catch. And then plus 2. Negative 7. Perfect. So we're at negative 7. Worries so far? We doing okay? All right, Sydney, you're up. So now I'm going to go 3 times what value? Excellent. And then plus, I got the 2 because that's the X value that I chose. The negative 3 I got from right here. Plus 2, I just made that up. That's my function machine. Each time I'm going to go times 3 and then plus 2. That's just what this machine does, you know? Okay, now, Sydney, back to you. You went 3 times negative 2, which is, and then? Perfect. Well said. Well said. Then I'm going 3 times. Viene, help me out. Equals. Good. Excellent. Gosh, let's pick on some more people. This is too much fun. Uh, Damien, help me out. Do the whole thing. Good. Good. Plus 2 equals. 8. You got it. Okay, hang in there. It's getting a little buzzy in the room. 3 times. Last one. Kaylee. Yeah. $14. See, you do have it. Good job. Thank you. Thank you. Okay, so now this is when, remember in our warm-up we had function. We talked about that. Takes an x, does something to it. Talked about domain and range. Now, domain and range might be new terms to you, but I'll bet in the old days you heard x referred as input. I'll bet you heard x referred to as input and y, or f of x, referred to as output. Who's heard those terms before? Input and output. Kaylee has? That is awesome. Okay, now we're going to add domain and range, and those may be new terms, and that's okay. For this particular function, exactly what we did here, Luis, you're up. The domain, that's not good. The domain is the set of x values that we used. The set of x values. Okay, Luis, what do you have? The set of x values. What x values did we use in this particular function? Perfect. -3, -2, 0, 2, and 4. And that's our domain, Kathy. Those are input values that we plugged into our function machine. And then for each value, we crank the handle, multiplied by 3. We crank the handle again, multiply or added 2, and it spit out the y values. And those y values are called the range. They're called the range. And Damien, what are my range values for this particular function? Yeah. -4, 2, 8, and 14. Brilliant. Thank you. Okay? That's cool. Questions so far? And that, of course, is the set of y values, or f of x values. Damien, are you waiting? Yeah. That is so thoughtful of you. Thank you, but go ahead. Now's a good time. Questions? Questions? Now that we've talked about this, who remembers a little bit about that? A little bit, Axel, a little bit, Kathy, a little bit. I know you've had this, but boy, they throw a lot of information at you over the years, so it's okay if you forget. It's all right. X value input, f of x output. Okay. Now, there is something new. Of course, there's more. Always. Never ending. And we're going to say that domain and range only exist if a relation is a function. We test this by using the vertical line test, Luis. You probably want to write that in your notes. Vertical line test. So it's going to look like this. Too many words? I know, it's a bummer. This, actually, you don't have to, because right now, Luis, I'm recording it. All you have to do is go on Google Classroom, and it'll be there for you. Oh, we'll show you. At the end of class, I'll show you an example. Okay, Jerry, help me out. Now, I draw a vertical line anywhere. Here's my vertical line in green. And I'm going to sweep the vertical line across different x values. Anywhere here that you hit more than one y value at a time, then it's not a function. So do I hit more than one y value for any x value? Jerry? No. So we say that this parabola, and you don't have to remember that, but that's what it is a function. Okay? This is a function. If it hits more than one value, then it's not. And I'll show you an example of one that is not. Let's say you took this same parabola, and I'm going to clone it, and let's say you took it and rotated it about the line y equals x. You don't have to know that, but that's what's happening. This would be the inverse of that parabola. And now let's apply the Jerry test to that same thing. Okay? We bring down our vertical line, and those should be black. That's going to get confusing otherwise. I'm going to change these. Make them black. Somebody has tunes on. Let's not. Because if you're fiddling with tunes, then you're not thinking about functions, which would be a bummer. Okay, so right here, notice this. What happens? The Jerry vertical line test fails. Fails the vertical line test. This relation is not. I would, but you don't have to. You can go watch it online. This is not a function. Okay? This is not a function. Questions on that, Sydney? Well, in order to define something in terms of x, we say there has to be a unique x value for every y value. It doesn't have to be the same the other way around. There can be we can repeat the y value more than once. That's fine, and I'll show you an example of that. But to define it as a function, and again, remember, Sydney, that mathematics is just a system of rules. It's like a language, and people have agreed upon rules. And we define things in terms of, and this will get back to one of our original terms. Thank you, Ms. Boatwright. It's getting a little buzzy. Sydney asked a really good question. We define things in terms of x's for this particular section, and the x becomes the dependent variable, and that was another one of the terms we looked at, and the y, or I'm sorry, independent, golly, I'm a mess this afternoon, independent, and the y is dependent upon the x. And what we're saying is we have a condition here, the x values, that are independent, and then in order for the y's to be dependent upon them, there has to be just a single x. Okay? And let's look at what this looks like for this one. If we did a t-chart for this. Sydney, pick a value right here. Negative, this looks like negative something. Give me a value. It doesn't matter what. Okay. We'll call this negative 2 right here. And we'll call this negative 3. And we'll call this, if that's negative 3, that's like 7. Doesn't matter. Okay? So if we're doing a t-chart for this, we have x and we have y, or f of x, a function of x. And our x is negative 2. And then we have 7 is one of them. And you have negative 2. And you have negative 3. Well, right here, this is a problem. And this, they say that both 7 and negative 3 map to negative 2, which will not make a function. Another way to look at that is if you just write this as a single negative 2 and say, you can put a negative 2 here and say, oh, look, negative 2 goes to 7, but it also goes to negative 3. And that doesn't work. Yes? At the same time. Good summary. Yes. Yes. Now, and that's fun. You know, that is a great summary. Now, let's look at it the other way around. Okay. I'll go down here so you can still see it. Let's look at it the other way around. What if you had that parabola again? So here we have that same 7. Notice we have 4 and negative 4. Both map to 7. That's okay. Because the x values are unique, it's not a problem. You can have negative 4, 7. You can have 4, 7. They map directly over. They don't map to the same y value, or I'm sorry, the same x value, so we're okay. This is fine. This is a function. This passes the vertical line test and is all groovy. This, however, is not. And I know that's kind of boring at this point, but as we get further into this material, I think you'll see the beauty of that system. And again, it's just a system that people agreed upon rules, and then we can speak the same language, in this case, math. Questions? Okay, we covered independent variable, we covered dependent variable, we covered range, we covered domain, we covered function. How many minutes are we into this? Oh, just about 20. That is probably enough. The one thing I will say, last, final, ultimate, is you're going to have to use the work that you developed for You're going to have to use the work that you developed for the inequalities to do domain and range for some of the ones today. So let's say this is 3 and 15. When you have a solid line here, this is called a continuous function. And you're going to say that the domain is all real numbers that go between 2 and 10. And we're going to have to use our inequality sign to write that. So what would that look like? Kendra, help me out. What's my lowest value here? 2. So I will write down 2. Ernest, what's my highest value? We're doing just domain, x's. Yeah, you're right, 10. Then put in your x in here. Then we're going to say, Luis, what kind of an inequality would I put here to say that x is related to 2 some way? Well, is x smaller than 2? Can we be over here? No. So then what sign would we use? Yeah, greater than. Do we need an or equal to? So this is filled in. We do not. We want to leave it like that. And then lastly, Naomi, help me out. Bring it home. X is going to be related to 10 how? So I can have values like 10 and 11 and 15. So we're going to be less than. Do I need an or equal to? Perfect. There's my domain. I'm going to end the recording now, but I want you all to write down on your paper what the range is going to be. So go to Google Classroom and watch this video. Thank you.